Hello my dear students. In this lecture I will show you that Coulomb's law and some fundamental postulates of electrostatics in free space. Uh, First of all, you have to know the electric field intensity. What is electric field intensity? The electric field intensity is defined as the force per unit charge that a very small stationary test charge experience when it is placed in a region where an electric field exists. How that can we understand? First of all, the thing is that if it is if there is a charge here, that is plus q charge, that means a positive charge, and it is placed in a region where electric field exists. There is a place. This place has an electric field, and at that point, it is defined as the force per unit charge that a very small stationary test charge experiences. That is a small stationary test charge that experiences the force, the electric force per unit charge in a region where an electric field exists. That means, as we know, in electric field is a force. If a test charge realizes a force in an electric field, then it is known as electric field intensity. That means force per unit charge. So it may be different points. Each point has a charge, and they state on a single medium of electric field. If they feel the same, so each charge that feels the force, that is known as the electric field intensity. E is equal to limit F divided by Q. The unit is volt per meter. Now the electric field intensity E is then proportional to and in the direction of the force F. That means it is proportional to F, and if F is measured newtons and charge Q is coulomb, then E is the newtons per coulomb in by C, which is the same as volts per meter. So the thing is that force per unit charge at a very small stationary test charge that experiences when it is placed in a region where an electric field exists, that is called known as electric field intensity. Now the theory comes. The test charge Q of course cannot be zero in a practice. As a matter of fact, it cannot be less than the charge on an electron. As we can see in this equation, as tends to 0. That means it tends to 0, but charge cannot be 0 in practice. As a matter of fact, it cannot be less than the charge of an electron. However, the finiteness of a test charge would not make the measured E after appreciably. That can't be 0. So it has a value. So after that, an inverse relation of this equation gives that. So we can write E is equal to, as Q is not gonna be 0, F divided by Q and for this we can write that F is equal to QB, and that is Newton. The two fundamental postulates of electrostatics in free space specify the divergence and curl of E. And what is divergence and what is curl? As we know, this thing, delta. Delta is a mathematical expression of a three-dimensional partial differential equation. Delta is like this. It is a vectorical sign. In these lectures or in this book, we try to find out all the bold phase letters as a vector sign. Okay, so that will be d dx, as it is known as partial differential equation, plus d dy. The d is like that, delta is like that, because it is a partial differential equation, ddz. So it's a three-dimensional space partial differential equation, and each side says that is I vector, x axis j vector,